Hey guys, welcome back to Data Products. In this video, we're going to be using a package called ggridges. And what ggridges is a package that allows you to have multiple kind of histograms or distributions all on one plot, and it's kind of like stacked. So it's kind of a different way of showing histograms instead of having, 6 histograms or all in their own panels or whatever. It's kind of a way to show similar data or distribution data all in one plot. It's kind of a unique tool. It's kind of cool. It's pretty visually appealing, especially if we add some components to it that we will in this video. So with that, let's go ahead and let's get to work. All right, first things first, open up our studio and create a new our markdown file. And we'll call this one, you can call it ridge plot, or you can call it ggridges if you want. Let's get rid of all this jazz, and first let's load the required packages. So we're gonna load 2 packages. We're gonna load ggplot2, and then one called ggridges. And if you don't have ggridges installed, you can do IOC manager install and then ggridges. So I already have it installed, so I'm gonna comment that out. But for those of you that don't have it installed, okay. So now let's load some sample data. So first thing we're going to do is I am going to, let me move my beautiful face here, and let's do air quality. And so, so the air quality data set here, it's from this New York air quality measurements, and so it's from May to September 1973. Where they took ozone, solar radiation, wind, temperature, month, and day, and measured those things. And so this is one of those sample data sets, kind of like the truth data or the motor trend car data, and there's a few others, popular ones at least. The flight data, if you took did my previous lectures. It's just a perfect size data set for this example. So that's why we're using it. It's not super biology-ish, which is kind of my intent, but it's available, so we'll use that. Okay, so now that you know what it is, let me put me back in my spot. Okay, so let's do this. Let's do air, because it's air quality data, and we're going to create a ggplot object, which we call ggplot air quality, and so it'll automatically grab the air quality data set from R. It's built in. We're going to add an aesthetic, which is temperature, month, and we're going to group it by month. And then we're going to add geom density ridges as our style, right? So let's run this. Oh, let's call air. So we print it out. Okay, and so you see this is like a histogram, right? So we have each month, and then we have the temperature, and this is also kind of the count, although we don't have a label on the axis for count. It shows us how often it was 82 degrees in, July, right? It's often 82 degrees. In May, the average temperature, you can see the distribution here is a lot lower, low 60s. Okay, so now let's try this. Now let's add some pizzazz here. We're gonna do this package called Viridis. We'll even say that. Now let's add some, how do you spell pizzazz? Pizzazz to our graph. Okay, And we're going to create another ggplot object. I'm not going to save it as a variable just to show that you can previously, but we're just going to print it right out. All right, essentially we're starting off the same way. 10th month group, oops, need to first of all spell month right. Ooh, my goodness. Group equals month. And then we're going to add this fill equals dot dot x dot dot because we're pulling that from the Viridis to get a certain style, and you'll see in a second here. Density ridges is our density ridges gradient is what our style that we're using. Before we used density ridges, that's how we got this gray one, but we're using this gradient thing now. And then scale, fill, Viridis, option. So you can choose what type of color you want here. So you saw those different colors. You can choose whatever one you want. I'm going to use C, and the name of our legend is going to be temp. Okay, so all that for, pizzazz, right? But it looks cool. So this is what we get. So we get our same ridge plot, right? But we have added a little bit. It's kind of the same information, right? So we have temperature that was on the bottom, but we've kind of accentuated it with adding this heat map to it. So colder colors are more blue, higher colors are more red. So you kind of get an added benefit of having this color map. So you can use this in different ways, though. If for example, you had three-dimensional data, right? You had month, you had temperature, and then you had something like the ozone amount. You could add the ozone as the color, and so then you have month and temperature, and then ozone as a third variable instead of making a 3D graph, which are very hard to interpret a lot of times, especially if you have clustered data. So that might be a novel way to do it, but it works well with temperature because, like infrared, like Predator vision, if you've seen the Predator movie, this is kind of how it shows up. Anyways, I'm getting kind of all over the place here. Okay, last thing. So last thing we will do is create a facet plot for all our data. So we can make multiple ridge plots together, and we've played with this in some of the past videos. So we're going to load tidyr just for the piping ability. And gather ability. So we're going to gather everything by measurement. And if you are finding this video on YouTube and you're like, I don't understand gather and all this stuff, I have a video. Look on my videos and there's a tidyr video. And so you can code along for now, but then if you want to dig deeper into tidyr, go ahead and check out that video. Alright, so our value is going to be value, because that's what it's called in our air quality set. Ozone, solar radiation, or R, wind, and temp. Those are the things that we are going to have facets for. So we pipe it down, and we're going to create a ggplot object, and value month group equals month. So we're saying, okay, we want our value and our month to be our two axes, and we're going to group everything by month. And then we want to tell it to do a geom density ridges. Let's do geom density ridges. I think that's fine. I had gradient in here, but we're not going to put the gradient on. So I think you could do the gradient, but if you don't give the color stuff, it just will make it gray. So, and then we're going to add facet wrap, and we're going to wrap by measurement, and then our scales are going to be free. All right, so there's a lot of mumbo jumbo. What do we get? Nothing. Here. All right, key equals measurement. Value equals value. Ozone. So did our wind temp. Ozone not found. Why is ozone not found? There's O-Z-O-N-E. Did I have a 0 there instead? No. Interesting. Ozone. So there are wind, temp. Let's look at our data here. Oh, forgot to call our data. All right, so up above here, it doesn't know where to look for our data. That's why I can't find it, right? So we have to say we're using the air quality data set before we do all this stuff. There we go. Okay. All right, so as you can see here, we have our ozone measurement on the top left. They all have the same month. Although, depending on how high the peak is, it adds more months because it's scaled to the heights of the peaks. So we have our ozone data. So you can see that ozone doesn't seem to really follow the same pattern as temperature. We have our solar radiation, we have our wind, we have our temperature, all these for each month. So we could say, okay, kind of what was the average solar radiation in July? And we could kind of figure out, okay, it looks like it's about 250, right? Kind of right. You can't really see my cursor very well, can you? But yeah, kind of like 250. So that is really it. So that's ridge plots. Kind of niche-y, I should say. They're not, you know, if you have a lot of distribution data and you want to display it and it's all for the same time frame, you can kind of put it like on those axes like that. It can be useful, especially if you put the heat maps on it. They look, you know, they can look pop if you have a poster presentation or a PowerPoint or something of that nature. But they're very kind of narrow in their scale, but they can be pretty cool too. So that's enough rambling. That's it for me. If you're watching on YouTube, hit subscribe. I'm going to be putting out more data visualization videos. I'm going to be adding Python videos in the future. Plenty of stuff. And stick around. We'll be doing more visualization, and I will catch you in the next one.